So in section 4.7 they talk about a bunch of different types of calculations. They talk about calculating the magnitude of an earthquake. They calculate the number of decibels of a sound. They talk about Newton's law of cooling, a bunch of different things. But I only focused on one type of problem for you to do in this section, so we'll just talk about that one. The pH scale. Now the pH scale is a number that ranges between 0 and 14. 0 is the pH. The pH of 0 is something like battery acid, and a pH of 14 is something like a liquid drain cleaner. 7 is right in the middle, and if you're less than 7, it is it's an acid, and if you're greater than 7, it's a base. Now the pH formula is calculated this way, and you write pH with a small p and a capital H. pH equals negative times log of this number. Now what's that number? This is the concentration of hydrogen ions. And now the concentration of hydrogen ions is written in scientific notation. It's actually in moles, but you don't really need to worry about that. So this is the formula you're going to use if they give you the hydrogen ion concentration. You just plug that in and you take the negative log of that number and you get your answer. If you want to solve it for H+, you can start with the formula and then multiply both sides by a negative and then rewrite it with, this is base 10 raised to that exponent equals the H+. Now if you don't follow that, I change H+ to an X, so you can maybe figure it out a little nicer. You multiply both sides by a negative and you get negative pH equals log X. And now rewriting this using rule 1, you get 10 raised to the negative pH equals X. And remember, the X is your hydrogen ion concentration, and it's written in scientific notation. So an example will be like 3.21 times 10 to the negative 4. Now if you choose, if you hit mode on your calculator and highlight scientific, SCI, and hit enter, now your numbers will be in scientific notation, and something like this on your calculator will show up as a 3.21 E negative 4. It won't say 3.21 times 10 to the negative 4, it'll just say 3.21 E negative 4, and you got to realize that that E means 10 to that power. Alright, so let's do some of these. First one says the pH reading of a glass of liquid is given. Find the hydrogen ion concentration. So if they give you the pH, you just plug in the pH. Oops, let's do the first one. Let's do question 1 first. They say find the pH for the given hydrogen ion concentration. So remember, pH equals negative log of H plus. And now here's your H plus for the first one, 5 times 10 to the negative 3. And if you ask a calculator what negative log of this number is, you just multiply, write it in as 5.0 times 10 hat negative 3, close parentheses. Okay, and you'll get 2.301. And do the same thing for this one, you'll get 3.495. And then for this one, you'll get 8.301. Alright. Find the pH for this concentration of hydrogen ion, so you plug that into the negative log, and you get 7.509. Now here they give you a pH, and they ask you to find the hydrogen ion concentration. So remember, the formula for that is 10 to the negative, whatever your pH is, equals your H plus. And it's always good to have this, your calculator, in scientific mode, scientific notation mode, when you do these. So 10 raised to the pH, negative pH, so 10 raised to the negative 3.0 is 0.001, or 1 times 10 to the negative 3. 10 to the negative, whatever the pH is, 6.5, gives you this number, 3.162 times 10 to the negative 7. Okay. And then this one, the pH is 4.6, so you plug in 4.6 into the exponent and make it negative. 10 to the negative 4.6 gives you that. 10 to the negative 7.3 gives you this. And now these, they're giving you the concentration of hydrogen ion and asking you to find the pH. They actually ask you to find the corresponding pH range when they give you the hydrogen ion concentration range. So you plug in each of these hydrogen ion concentrations into the log, and you take the negative log of that number, and you get this pH, and do the same thing for the second one, you get that pH, and so your pH is between these two numbers. And then number 7 says a certain wine has a pH of 32, another one has a pH of 29. Find their corresponding hydrogen ion concentration. So you say for 3.2 it's 10 to the negative 3.2, gives you this number. 2.9 gives you 10 to the negative 2.9, gives you this number. Now they ask you which has the lower hydrogen ion concentration. If you write these without scientific notation, you're moving the decimal over 4 places. So it was here between the 6 and the 3. 1, 2, 3, 4 places over. And then for this one, you move it over 3 places. 1, 2, 3 places. Now to compare these two, you should have the same number of decimal places, so add zeros as needed. So you get 1, 2, 3, 4, 5, 6, 7 decimal places there. You get 1, 2, 3, 4, 5, 6, and I added another 0 to make it 7 there. Now how do you know which one's bigger? Well, if you just read it, if they both have the same number of decimal places, and you read them without the decimal, you get 6,000 here, and you get 12,000 something there. Well, 12,000 is bigger than 6,000, so this one with a pH of 3.2 is lower or smaller than the one with the 2.9 pH. So the one with the pH 3.2 is lower concentration, lower hydrogen ion concentration. Okay.